So in the last chapter, we learned how to graph inequalities, and we graphed them one at a time, and we showed their solutions by shading in an area on the coordinate plane where the solutions for the inequality were true. So a system of inequalities is just, in this case, we're going to talk about a pair of inequalities. So let's define our system of inequalities as a set of inequalities with the same variables. So just like in our system of equations, we were dealing with the same variables in both equations, our inequalities will be similar. They'll almost look exactly the same as systems of equations, only we're using inequality signs instead of equality signs. So an example could look like y is greater than negative 3x plus 2. And we could have another inequality where y is less than, negative 2/3 x. So a solution for a system of inequalities is a little different than a solution for a system of equations. So remember when we graphed inequalities and the solutions were a shaded area? When we graph a system of inequalities, we're going to look for a shaded area as well, but we're going to look for the shaded area where the inequalities solutions overlap. So a solution for a system of inequalities is just the ordered pairs that are solutions for both inequalities. In other words, we're looking for the shared ordered pairs by both of the inequalities. Now I'm going to sketch an example. So here's my coordinate plane. Okay, so not going off the example at the top, let's just say we had an inequality that looked like this, and say its solution was this area below the line. And let's say we had another inequality that looked like this, and its solution was this area above the line. The solution for the system would be the area of overlap. So this area right in here, where the inequalities overlap, the shared solutions. So let's go ahead and look at a few examples where we're going to graph these inequalities, and we are going to find the area where their solutions occur. So remember, graphing inequalities, we treat the inequalities first as if they were equations, just so we can get the line on the graph. So let's take a look at our first inequality. Let's treat it like an equation, so we just put an equal sign in place of the inequality sign. So y equals negative, or the opposite of x, plus 1. So let's graph this. Starting at the origin point, let's find our y-intercept, which is 1. And we know our slope is negative 1, so we're going to go from our point down 1 and right 1. Now remember, to determine if we're going to draw a solid line or a dotted line, we need to look at the original inequality. Now this is a less than sign, so we do a dotted line. If it were less than or equal to, we would do a solid line. So here's our dotted line. All right, now to determine which side of the graph we need to shade, remember we have to pick a test point. And if we plug in our test point back into the original inequality and it gives us a true statement, we know we shade the same side of the coordinate plane as was on the test point. If we plug our test point in and get a statement that is untrue, we know we need to shade the opposite side on our coordinate plane. So with our first inequality, remember we have y less than opposite of x plus 1. Let's pick our test point. And remember to always pick test points that are easy. In this case, the origin is a test point we could use, so let's use 0, 0 as our test point. Go ahead and plug your test point in back to your original inequality. So our y-coordinate is 0, less than, well, our x-coordinate is 0. Let's go ahead and simplify now. The opposite of 0 is just 0, and 0 plus 1 is 1. And 0 is less than 1, so we get a true statement. So we know we need to shade the same side of the coordinate plane as where our test point was. Okay, so we know this whole area is going to be a solution for our first inequality. Now let's do our second inequality. Remember, to graph it, we treat it like it was an equation. So y equal to, we put in an equal sign instead of our inequality sign, 2x plus 3. So let's graph this. We know our y-intercept is 3, so let's start at 3. 1, 2, 3. And our slope is 2, or 2 over 1. So from our point, let's go up 2 and right 1. Now to decide if we need a solid line or a dotted line, let's look back at our original inequality, and it's a less than sign, so we know we need to have a dotted line. So there's our dotted line. Now we need to decide which side of the coordinate plane we need to shade. So taking our original inequality, y less than 2x plus 3, we need to pick a test point. Now it looks like our easiest test point again is going to be the origin, so let's choose the origin. And remember, if it's a true statement, we're going to shade the same side of the coordinate plane as the test point. If it gives us an untrue statement, we're going to shade the opposite side. So let's go ahead and see. Putting in your test point, 0 less than 2 times 0 plus 3. Simplifying, we end up getting 0 is less than 3, which is true. So let's go ahead and shade the same side of the coordinate plane as our test point. Now we're looking for the spot where, or the area where, our inequality solutions overlap. And it looks like it's in this area right here. So this area is filled with solutions for our inequality. So our solutions are in here, in this area. All right, let's do one more example of a case where we end up with no solution. All right, so here are two inequalities. Remember, we need to graph them as if they were equations. So let's take our first equation. All right, so we're starting with x minus y. Remember, we change our inequality to an equal sign when we're trying to graph it. Now let's put it in slope-intercept form, as I think that is easiest to graph on the coordinate plane. So let's subtract x on both sides. And let's get that y by itself, so divide through by -1, or you can multiply through by -1. We get y equals x plus 1. So let's graph that. Our y-intercept is 1. Our slope is 1, so let's go up 1 over 1. Now we need to do a dotted line since our original inequality is without an equal. So it's a less than or a greater than, and it is not equal to. So go ahead and draw your dotted line. All right, now let's do our test point to find the solutions for our first inequality. So the original inequality is x minus y less than -1. And let's choose a test point. Now we could use the origin again, but I'm going to use a different point since we used the origin in our last example. Let's use this point right here as our test point, and that's the point 1, -1. So let's put our test point into our inequality. So x is 1 minus y is -1 less than -1. So subtracting -1 is the same as adding 1, so 2 less than -1. Now that statement is not true. So we know we need to shade the other side of the line for our solutions to this first inequality. All right, let's go ahead and look at our second inequality. Let's graph it. So we treat the inequality as if it were an equation. And let's put that equation into slope-intercept form so we can more easily graph it. Okay, simplify. We end up with y equals x minus 3. So let's graph it. So our y-intercept is negative 3, 1, 2, 3. And our slope is 1, so up 1 over 1. And we're using a dotted line. Since our original inequality was a greater than or less than without the equal to part. So now we need to pick a test point for our second inequality to find out which side of the coordinate plane we need to shade. So back to our original inequality, x minus y greater than 3. Let's pick our test point. And let's go ahead and pick a test point maybe down here this time. We could use the same test point as we did before, but I'm going to show a different example. So this point, 1, 2, 3, 1, 2, 3. So 3, negative 3. You put that back into your original inequality. So x is 3 minus y is negative 3 greater than 3. So subtracting negative 3 is the same as adding 3. You end up with 6 greater than 3. And that's a true statement. So we know we need to shade the same side of the line as our test point was on. Now let's see where these inequalities share points. Where do they overlap with their solutions? And in fact, it's nowhere. There is no overlap. So this is a case of no solution.